Senior PFE from Microsoft Austria, and I'm going to talk to you today a bit about application request routing and the Web Application Proxy, the component that ships in 2012 R2. So we're going to start off with a choice. So the choice we have is really, what do we want to do? So we have a couple of choices here. So commonly people for Exchange deployments used TMG. MCS was selling TMG like crazy, right? So with every Exchange deployment, we were kind of positioning a TMG environment as well. Seeing that the product group decided that TMG is no longer in our strategic route, the decision that we need to make is on what do we want besides TMG, or UHE for that matter. And we have a couple of options. First option obviously is just nothing at all, and that's actually what MSIT and Office 365 is doing. They don't have any reverse proxying, they don't have any pre-authentication there. Second option is obviously a third party. So there are a couple of third party options out there. You have heard about them. There's Camp ESPs out there. There's a bunch of airlock boxes out there. All kinds of stuff that does the job. And we have a couple of options really from our perspective as well. So what we have is our application request routing, or the Web Application Proxy. And kind of depending on your requirements that you have in your environment, both of them get the job done really. The big difference between the Web Application Proxy and R in terms of functionality is that the Web Application Proxy can do pre-authentication for some protocols at the moment, not for all protocols, but for some protocols, which the application request routing component cannot do. It does require a bit of more tweaking. It has a bit more prerequisites, but overall, the Web Application Proxy is definitely the component that is our strategic way of going forward. By saying strategic way of going forward, I kind of mean that this is the component that will actually get the work done. So the Web Application Proxy will see its fair share of work in future product versions, while the application request routing component is kind of like I would not call it necessarily a side gig of the IS folks, but that's kind of what it is really at that stage. All right, so let's jump in with R, each and every pirate's favorite letter. So what is R? R is basically nothing more and nothing less than an IIS extension. So when you go to the IIS.net site and Bing for R, you're going to get to the download page for that, which is just going to install a bunch of extensions for IIS there. Prerequisites for that, not really much. It's just working starting from IIS 7 to the newer IIS versions on 2008 R2 and 2012 R2 as well. No other prerequisites really, no need to be domain joined, seeing that we cannot do any pre-authentication. There is no need to be domain joined there. There is no configuration sharing when IIS is joined to domain, so there's no real need for it to be domain joined, just from the R perspective. There might be a need for it to be domain joined from a manageability perspective or something else, but not for the just not for the actual publishing perspective. All right, so R brings us multiple features really. We're not going to use all of those features, and we're not going to talk about all of those features. So we're only going to talk about the features that we're going to use for Exchange itself. So what R gives us is, in fact, a reverse proxy, kind of like TMG did. It brings us load balancing, kind of like TMG did. It brings us health checking, kind of like TMG had as well. And multiple other things like routing decisions at layer 7, layer 4. We can introduce a cookie-based affinity there. We can do SSL offloading if you want to do that. It's supported since 2013 SP1 again. Okay, so let's have a look at the components that are involved in the application request router. So what you have here is like a quick overview. You have your Exchange protocols up there. You have Outlook Web Access, Outlook ActiveSync, ECP. That could be Outlook Anywhere. That could be MAP HTTP, whatever. And you have like your free Exchange boxes there at the bottom. And in the middle, there's this green empty box right now, which says IISR. And we're going to fill it with components now. And we're really only going to use two components of R. And the two components we're going to use are the URL rewriting module, which is basically our reverse proxy, and a URL filter, really, so you can come up with different filters where you say, yeah, access to this URL needs to be redirected to somewhere else, access to this URL needs to be rewritten to this destination. And you can like put in deny rules as well, just like you could in TMG. And we're going to use the Web Farm Framework module. And the Web Farm Framework module basically is a free load balancing module. So what this does really is just think of a TMG web farm, really, a TMG web server farm. The TMG web server farm, really, you added a bunch of boxes, and the traffic was directed to those boxes. Now, with the Web Farm Framework, there are a bunch of more methods to configure that, and we'll have a look at that in a slide further down the line. All right, so when any request comes in, we're going to have a look at that request first in the URL rewriting module. So the URL rewriting module is going to check if the request is actually valid, if there is a matching rewriting rule for the request that's coming in. And if there is a matching request for that, we're going to redirect or reverse proxy that traffic accordingly to the web farm. The web farm, again, is only like a collection of Exchange servers that will serve up the requested page, like OWA or ECP or RPC proxy or whatever you want to get to. The web farm the web farm itself is going to do the load balancing. So depending on how we configure the web farm, it's going to go back to the web farm and just direct the traffic to the appropriate Exchange server in the backend. All right, we kind of talked a bit about that. It's the actual reverse proxy. It's kind of powerful, though. It has very powerful filtering capabilities. So the pattern matching engine understands regex patterns, really. So you can come up with some very clever stuff there. This is also the component that can do HTTP, HTTPS redirects if you're looking for that. So this is where the URL rewriting module comes in handy besides the reverse proxying part. And we talk a bit about the Web Farm Framework, which I said free load balancing. Okay, so we have bunch of different algorithms in there, 7 indeed. Least connections, round robin, there are a bunch of more, and we're going to talk a bit about these in a slide down. We have a proper health testing in there, so we can go ahead and do a health test for the directories we want to talk to. Like, for example, in Exchange 2013, we can directly go for the /healthcheck.htm files and check our status there. In the older versions of Exchange, 2007, 2010, we can obviously still go for the 200, 300 responses, but we cannot go for the health check HTM response because it's not there. It started in 2013, really. All right, let's have a look. We're going to talk through 3 options, really, on how to deploy the application request routing components. And my understanding is that the 2 options are documented publicly on a blog, and the 3rd option is, I think it was never really published, but I think the work is done to be published, really. All right, let's have a look at the option 1, and just a couple of steps really for your reference, showing you how to configure that. So I attached the PowerPoint file as an attachment to this link call, so you can download the PowerPoint from there and use it as a reference to build your own labs and deployments. So basic couple of steps really. So first step in every R deployment is to start off with a fresh server farm. And again, the fresh server farm is basically our load balancing. So it's going to ask you for a name, it's going to ask you for all the servers you want in there, and it's going to ask you if it should create a URL rewriting rule for you already. So the URL rewriting rule, again, is the actually reverse proxy part. So as soon as you create a server farm, it's going to ask you, hey man, you just created a server farm. Do you want to have a rewriting rule corresponding to that server farm as well? If you say yes, it's going to auto-create a simple one for you. If you say no, you need to do it later on manually. All right, couple of modifications really. We don't do any caching when publishing Exchange, so this needs to be disabled. Load balancing, we kind of talked a bit about the different forms of load balancing there. So my obvious pick is least current request here. So I want to have the requests distributed evenly. So yeah, just pick your option there. And couple of more modifications needed for the application request routing engine to work. We need to increase the timeout a bit, and a very crucial one is the response buffer threshold here at the very bottom where it says 0. So this, I think, per default is 64K, and there's a bunch of stuff not working when you do not set that. So the one thing that's definitely not working, for example, is OWA notifications. They just don't work if the response buffer threshold is set up. So the server farm brings us health checking. We quickly talked about that. So in that case, I'm going to say, yep, dear application request routing, please go ahead and check my farm, which is in that case is called mailser8.at. Please check this farm every 5 seconds and see if it's actually there. And he said, yeah, do this every 5 seconds. And if the result is a pass, direct traffic there. And if the result is a fail, don't direct traffic there. So in that case, I added like a fake server, a second server in there, which is not actually existent. And it determined that it's not there. It could be the same story if the IIS component is offline or whatever. It would just not be answering that, and I wouldn't get a 200 error code back. All right. Last step, URL rewriting rules. It's the reverse proxy part, really, and we ask the wizard to create a default URL rewriting rule. And this is kind of like how the URL rewriting rule looks. I'm just going to add all of the slides here, all the boxes here. So in that case, we're going to have a URL rewriting rule that's going to capture everything, really. It's going to capture star at that stage. So we're going to say everything that's coming in for HTTPS whack mail.ser8.at/star should be handled by that rule, really. So if you have a look at the conditions window, the one window on the left, really, it says that there are two conditions, really. The first condition is HTTPS matches on, which is just saying if the traffic is HTTPS. It needs to be HTTPS. If it's not HTTPS, we're just not going to listen for it. And the second condition is if the HTTP host value, which is the center part or the FQDM part of the URL, matches mail.ser8.at, which is just my development environment, really, then go ahead and fire this rule. All right. So in that stage, the URL rewriting rule performs an action, and the action that it's really doing is to route to a server farm in our case. It could be different actions. So it could be a redirection to somewhere else. It could be a rewrite, but we want to do a route to a server farm, and the server farm is the one we already created. And the only thing that's really modified in here from the default rule that's being created is the scheme in here and the conditions up front. The rest was pre-created by the wizard, really. So a couple of steps, really. Just download the deck as a documentation and play with it in your labs. It's going to work just fine. And this is what the first option would look like. And we're going to talk a bit about the different options, really. But the first option we're going to talk about would have two namespaces. One would be mail.blah, blah, blah, and the other one would be autodiscover.blah, blah, blah, really. Okay, so let's have a look at the option one. What does option one really mean? Option one is an option where I have a shared namespace for the protocols, which means I'm going to have in that example, mail.contoso.com/OWA, mail.contoso.com/ECP, mail.contoso.com/RPC, and so on and so forth. And I have autodiscover.contoso.com, obviously, because my client will not call from mail.contoso.com/autodiscover in the default scenario. Okay, so how does the option one work? We created two URL rewriting rules. We created two server farms. That's about it, right? So we kind of walked through the configuration steps 2 times. All right, so let's have a look. So let's start with the autodiscover call first. So Outlook, whenever you open it up, is going to perform an autodiscover call. And the autodiscover call is not the first rule in the sequence. So the R component, the URL rewriting module, will need to have a look at mail.contoso.com. Is this rule going to fire? Nope, because the HTTPS host, the HTTP host value is not going to match. So it's going to try the second one, the autodiscover contoso.com. And it's going to say, yep, that's the one, really. And the autodiscover contoso.com should be redirecting or proxying the traffic to the autodiscover contoso.com web farm. And as you can see, at the bottom, one of those CAS boxes, of those Exchange 2013 CAS boxes, is being marked unhealthy. So it didn't return a proper health check value. So we marked it as unhealthy, and we're just going to get the traffic to the two healthy boxes. Same story for EWS, for example. In that case, the first rule would be firing. Would go to the mail.contoso.com web farm in that scenario. And we can see that CAS 1 is marked as unhealthy here, so we would redirect it or proxy the traffic to the other two healthy CASes. So when you have a look at that, and where it says mail.contoso.com web farm, it says health check for WAC OWA, WAC health check HTM, which kind of means that whatever protocol is coming along, EWS, OAB, ECP, whatever, is going to be proxied to that server as long as OWA returns a healthy status, right? So if EWS is actually broken on CAS 2 and CAS 3 in that scenario, we don't care, we don't see it. So we would still point traffic to that, which is actually the quirks of option 1, really. So ISR is going to go ahead and do a health check for OWA, which is answering 200 OK in our scenario. Do not check if EWS or OAB or whatever are OK. So if a request comes in for OAB and OAB would be unhealthy on CAS 1, we will still proxy traffic to it and the client request would actually fail. Same story for EWS. Client request would actually fail if the EWS virtual directory would be broken. All right. So there's a solution to that. It's not a pretty solution, but it's a solution to that. And the solution is a per protocol namespace with a per protocol health check. So in that case, as you can see, we do no longer have a shared namespace like only mail.contoso.com. We now have mail.contoso.com, ECP contoso.com, EWS, EAS, OAB, Outlook Anywhere, Autodiscover, you name it, .contoso.com, which is a pain in the ass, sorry, to configure, and but in all honesty, the only URL that the client really needs to know is the URL for OWA, right? Because all the other components like ECP, like EWS, like Outlook Anywhere, like MAPI HTTP should be given out by Autodiscover. So yes, you would need some more work. You would need either a wildcard certificate or a certificate with more SAN names up there, and a bit more of a configuration. But obviously, if I can now do a per namespace scenario, a single namespace per protocol scenario, I can obviously come up with a better health checking scenario. So I can have a OWA WAC health check HTM for OWA. For ECP, I can have the ECP health check HTM, and so on and so forth. Downside of that, again, multiple namespaces need to have either a wildcard or a SAN certificate for that, and a bit more configuration really at that stage. All right, let's have a look at the options we have really. And I talked about 3 options, so there's one missing really, and the option 3 really came up later on in the game, and it actually came up when we played around with it a bit more and saw that we could actually come up with a per protocol health check and still share a common namespace scenario. So the difference between those really, if you have a look at that, is so the pink boxes are kind of the best of both worlds really. So option 2 has the per protocol health check, and 1 has the common namespace, which we would want to have. And option 3 really gives us those 2 together. And we'll have a look at that and how that goes. And the idea is that we're going to use the regex capabilities of the URL rewriting rules. So the idea is that I still have multiple server farms. I still need multiple server farms, obviously, because otherwise I wouldn't be able to do a proper health check for the protocols. So I still need a server farm for OWA, I still need a server farm for ECP, for EWS, and so forth. And the idea behind this is that I would want to have a single shared namespace up there. And the idea is that that we will do different URL rewriting rules in there. One would be WAC OWA star, the one would be WAC ECP star, and so on and so forth really at that stage. So what we would come up is different rewriting rules that would all listen on mail.contoso.com, but would also be triggered on the first word that comes after the WAC after mailcontour.com. So we would go for OWA star ECP star in the URL rewriting rules. So with that simple trick, we can actually have still one namespace and do per protocol health checks in R and get this to work with a much smoother setup, really, with only 2 domain names in the certificate, with only 2 published names like mailcontour.com and my scenario autodiscover.contour.com. All right. So let's have a look at. I'm going to answer questions after the because I'm seeing someone is already typing in the IM window. I'm going to answer questions after the presentation, really. The application request routing box itself doesn't bring any high availability with itself. So it's a standalone box, really. So it needs some form of NLP itself. Windows NLP at that stage is fully supported, so are third-party NLPs, obviously. The question is, if you're going to go for a third-party NLP, is R the appropriate choice for it? Probably not. So at that stage, WinNLP is a good choice, really. And keep in mind that with 2013, really, you do not need any server affinity, really, anymore. One thing, if you want to go ahead and bring up multiple R boxes, is you can leverage the EIS shared config. So you can have like a primary box that's going to be the one that's going to give you out like a master config. I copied in the link for that, and there's like an active and passive and active and active a combination doable for that. All right. We only talked about Exchange 2013. Exchange 2010, Exchange 2007, well, yes, you can do those as well. If you have 2007, 2010, 2013 in the mix, you obviously need to provide the legacy namespace as well. You also cannot use the health check HTM because it's not there in 2010 and 2007, so you need to come up with a different health test, really. So in my case, I'm going to go with just WAC OWA, and the acceptable status code is 200-2399, really, which is basically meaning the box is there. It's not giving me a 500 internal server error, nothing. So that should be good. All right. So I'm just going to look at the first question that came. Is this feature meant to replace the TMG and you can as IS flash server publishing, provide load balancing and health check for published servers? Well, you can replace TMG partly with it, right? TMG could do more. It could do pre-authentication for more protocols. It could do pre-authentication for EAS. It could do pre-authentication for all the protocols, really, in all honesty, which R cannot do at all. When it comes to load balancing of the whole thing and health checking the thing, yeah, it's a good one. If you still rely on pre-authentication in the DMZ or in the parameter network, no, R will not cut it for you. All right. Second part, really, Web Application Proxy. The Web Application Proxy, in my opinion, the more interesting bit, really. The Web Application Proxy was introduced in 2012 R2 and is part of the remote access rule. Couple of prerequisites, really. The Web Application Proxy requires an ADFS 2012 R2 installation. Yes, even if we do not want to do any ADFS configuration, even if we do not want to do pre-authentication with web, we still need at least one ADFS 2012 R2 installation because web stores its configuration in there. So this is mandatory. The thing that's kind of nice is that you do not need to deploy domain joined. It can be domain joined or not domain joined. And we do not require a 2012 R2DC or forest level or domain level or whatever. So if you're still on 2008 R2 or 2008 or whatever, we would still be fine because we only need the ADFS 2012 R2 role. So what's the Web Application Proxy? So the Web Application Proxy really has two roles to it. So the first role really is to replace the old ADFS proxy. So the ADFS proxy formerly was a downloadable component that you were able to install on a standalone box, and it provided you a GUI for users to log on to ADFS really at that stage. So this is going to be replaced by the Web Application Proxy. And the second part that we're actually interested in is the capability to do reverse proxying for us. So we're going to use the Web Application Proxy to perform reverse proxying for us. It's designed to be deployed in the DMZ. Honestly, you can deploy it anywhere you want to. The basic diagram shows it in a DMZ, so that's kind of where I want it to be. Let's have a look at the topology, really. So this is kind of how that looks. We would have our corporate network in the backend, where we have a backend server, really, and the backend server in our case would be any version of Exchange, really. We would need ADFS. We would need, obviously, the domain controller in there. And we have the Web Application Proxy in the middle in the DMZ, really. And kind of different to what TMG did. TMG was its own firewall, really. Web Application has no firewall really built in, really. So that's kind of why you see a firewall in front and behind of the Web Application Proxy. The idea of TMG really was to have like one leg already published in the internet. I know most people still sandwiched even TMG between two firewalls, but the idea was to actually have one leg of TMG facing the internet. Web Application Proxy expects to be behind the firewall, so it's cool with that. The only traffic that's going to go to and from ADFS is HTTPS traffic, really. So between those firewalls, the only port that's really, that really needs to be open is HTTPS, which is kind of nice. Okay, Web and Exchange, really. So we can publish any protocol in Exchange that we have with Web. So we can publish OWA, obviously. We can publish the newer protocols like MAPI, HTTP. So that's actually working. The thing that's currently a limitation of Web, which is kind of boring, I get it, is that we can only perform pre-authentication for OWA ECP at the moment. The problem is that the way that we do pre-authentication for Web and Exchange is that we redirect the client to the forms logon page of the ADFS proxy. The thing is that a standard browser will understand that, but an Outlook client or an ActiveSync client would not understand that redirection. And that's kind of the reason why we do not have that by now. Saying that, it has been officially announced that authentication or pre-authentication support for other protocols will be coming. We kind of announced it at MEC 2014. So it's kind of a time thing until we have pre-authentication for other protocols as well. All right, let's have a look at that. And this is kind of like a quick deep dive into how authentication works with ADFS and the web proxy in the picture. So this is the authentication flow for Exchange 2013, Exchange 2010, Exchange 2007, really. There's kind of a difference if you're on Exchange 2013 SP1 because you could use ADFS authentication already, like claims-based authentication, which is the same idea, really. It's just differing in the last two steps, really. All right. So we have a bunch of URLs there. We have an internal network where the Exchange boxes sit. We have ADFS in there, and we have the Web Application Proxy in the DMZ, really. Okay, so a bunch of URLs. We have mailfabricam.com, and we have stsfabricam.com, which is our ADFS logon portal. Okay, so if I'm the user sitting outside of the firewall, I'm going to type in my browser https mailfabricam.com, and the first thing that's going to happen is I'm going to be redirected. So keep in mind the SIR8 AT is just, again, my test environment in there, so just forgive me for that. So we're going to see a 307 temporary redirect, which is going to bounce me over to my ADFS logon window. You probably have all seen that before. It's nothing new, nothing fancy. And it's going to ask me now for my credentials to log on. Okay, so I'm going to hammer in my credentials, my super secret password, as you can see in here. So these are actually just fiddler traces that I took off the logon process. So I'm going to post my credentials to the Web Application Proxy. And the thing is that I'm actually not authenticating for the Web Application Proxy or for Exchange now. So the first thing that I need to do is I need to authenticate for ADFS itself. So I'm kind of asking if you can see that, like in the first URL and the post URL, there's like a realm in there and a URN, and there's a word called app proxy in there, which is kind of ADFS's way of understanding that what I really want is authentication for the web application proxy. The thing is that ADFS says, yeah, you can have authentication for the web application proxy, but I don't know you. You need to authenticate against me first, and after that you can come again, and I'll going to give you authentication for the web application proxy. So the first authentication flow that we see here is going to go against the ADFS box itself. So with that one, we're going to go for ADFS, and we're going to get back an MSI as off cookie. And the MSI as off cookie is really good for authentication at the ADFS box itself. So with that cookie, we can authenticate against ADFS. All right. So with that in mind, we're going to go with the exact same URL again. If you have a look at the slide here, we asked for actually asked for a app proxy credential, and we have a client request ID, which is just a sequence number, which is useful for tracing, really. And as soon as we get the MSI as off cookie, we're going to go to the exact same URL again. We're going to go ask for an app proxy authentication again, but this time we're going to add the MSI as off cookie, which kind of tells ADFS, hey, you have authenticated to me before. So ADFS sees that cookie and says, yep, I do know you. You have the right to go to the web application proxy. So we're going to give out what we call an auth token. And the auth token in that case is good for the web application proxy. The auth token at that stage is a base64 encoded blob of data, if I'm not mistaken. I think it's base64. So if you would take everything after auth token and put it into a base64 decoder, you would actually see how your claim is being constructed. So how many claims are in there? Is the UPN claim? Is there in there? Are the group SID claims in there? Whatever is in there, I could really be deciphered by just pasting that in a base64 decoder. Okay, so with that auth token, we can go back to our web application proxy and show that token. So we're now going to say, yep, dear web application proxy, I want to go to my original URL, and I want to show you my auth token. And with that auth token, the web application proxy is going to do its KCD story. So the whole thing is taking my credentials, verifying them against ADFS. It's going to get back a auth token cookie, an auth token string at that stage. It's not a cookie, really, it's just a string at that stage. And web application proxy is going to ask a Active Directory for a KCD ticket for my name. So we have Kerberos delegation configured in that example. And at that stage, the web application proxy will show that ticket against the 2013, 2010, 2007 CAS boxes. At that stage, we are fully logged on. The user sees its mask, he's logged on, he's happy to work. Every further request that we're going to see is not going to contain the auth token anymore. It's going to contain an edge access cookie instead. Difference between the auth token and the edge access cookie is practically nothing. The only thing is that the edge access cookie is encrypted with a key that's stored in the configuration database of the web application proxy. And the reason for that is quite simple. So with the edge access cookie, you kind of authenticate against your web application proxy. And if you have more than one web application proxy, the idea is that regardless which web application proxy you hit, each web application proxy should be able to decrypt that edge access cookie. And seeing that all web application proxies that are serving one application should be joined to the same ADFS instance, those web application proxies share the same configuration and share the same key. Henceforth, each web application proxy can decrypt this edge access cookie and can log you on silently. So in case you hit one web application proxy on your first hit, on the other web application proxy on your second hit, you will not be asked for re-authentication. You will just transparently be signed on. There's nothing going to change, which kind of allows us to do load balancing between web application proxies without providing for any affinity. So that being said, well, password authentication. I'm going to spare you the password authentication, really, which is just boring, really, at that stage. Okay, I have the load balancing slides a bit later on, so hang with me. Okay, so again, edge access cookie, nothing more than an encrypted form of the auth token used by the web application proxy, can be decrypted with the shared key that's in there, which gets us to a point where we can silently log on people if they move over to another web application proxy, in case one application proxy dies, or in case if you're doing round robin for web application proxy or whatever. Okay, cool. So let's have a very quick look at the password authentication, which is no pre-authentication. So this is the version where we can do all protocols with, which is basically just going to give you back a unauthorized 401 error when you first log on. On the second try, you're going to give them your, in my case, negotiate credentials, NTLM credentials, and be logged on. So this would be your traditional reverse proxying way without doing pre-authentication. Okay. All right. So there's one thing more I want to talk about. Is 2013 SP1. I kind of mentioned it before. Finally got us ADFS authentication back. So we can now do native claims-based authentication against Exchange 2013 again. If you remember, there was like a white paper floating around on the internet in the 2007 timeframe, which quickly disappeared again, which was briefly, if I remember correctly, it was actually briefly supported, then not supported for quite a while, and now it's finally supported again. A couple of caveats though. So the first thing is you cannot mix and match. There's no way you can have forms-based authentication, NTLM, basic, whatever, secret knock signs mixed with ADFS. So you pick one or the other, really. So if you if you want to have ADFS for OWA, there's no way you're going to get FBA, NTLM, or whatever on the same virtual directory. There is no support for coexistence at the moment. So if you're running on 2013 SP1 and you're trying to open up a mailbox that's on 2013 non-SP1, meaning older than SP1, or 2010 or 2007, this will just not work. Another thing is that you could use either ADFS or the web proxy, really. So in my case, the web proxy is only acting as an ADFS proxy to claim the claim, really. The thing is that Exchange will just redirect you. It will redirect you to an ADFS URL of your choice, and that could be the ADFS box directly, or that could be the web server. Both work just fine. We can also do pre-authentication now without having the need to be domain joined finally again. So the idea is that with web in place and 2013 SP1 and ADFS authentication, there is no need for the web box to be domain joined anymore. So for the scenario that I just showed you for the whole KCD story, KCD, Kerberos Constraint Delegation, obviously requires some form of domain join. Otherwise, the web proxy cannot go and obtain a ticket. With a claim, I mean, a claim is just a piece of text floating around, really. So as long as Exchange trusts the claim provider and the claim is valid, we're just going to log the person on, really, at that stage, which is quite nice. There are detailed configuration steps out there, finally. So I posted a short URL to that. Basic steps require that you need to have a so-called relying party trust in ADFS, which is basically relying party trust is authentication credentials flowing out of ADFS to Exchange. The documentation says that we need UPN claims, we need primary seed and group seed claims. If you try it in the lab, you will find out that if you only issue an UPN claim, stuff will work just fine. The primary seed and group seed thing was required in the beta steps, really, and the guidance seems to have been written during the beta days, so it still says you need to have primary seed and a group seed claim in there. A couple of things that you need to configure on the Exchange side. There is an ADFS issuer, audience URIs, and a thumbprint, which is basically the ADFS signing certificate thumbprint, which is all very, very nicely documented in the mentioned document here. Last step, OWA, ECP virtual directories, you need to disable all forms of authentication on there, like forms, basic, NTLM, turn them all off, and then turn ADFS authentication on. And if you do that, you will actually see claims authentication working, and that's the one that I'm actually going to demo for you in the end. All right. Just like the R box, Web has no inbuilt high availability. So the Web Application Proxy itself is a single point of failure. If you want to have more Web Application Proxies, well, just build out more and subscribe them to the same ADFS store, to the same ADFS farm, really. So by subscribing them to the same ADFS store, you get the same config over to the Web Application Proxy, and they will also share the decryption key for the edge access cookie. So if a client connects to the web application server on the left first and then fails over to the one on the right, he will not need to re-authenticate because this guy will be able to decrypt the cookie over there. Again, no need for affinity there. So Windows NLB, just fine. Third party, obviously, just fine as well. So we can deal with both really at that stage. All right. Couple of steps, again, for your reference. Again, please download the PowerPoint from the attachments. It kind of talks you through on how to configure relying party trust. And as you can see here, we have a relying party trust. And relying party trust is really claims flowing out of ADFS. If you have a look at claims provider trusts, those are really authentication claims that flow into ADFS. And we're going to have a look at that in the lab in just a minute. All right, so we want a claims provider trust, really. A relying party trust really at that stage that will give the authentication over to Exchange. So we need credentials flowing out of ADFS. And we go ahead and just configure it. It's just for your reference in here. And the thing that's kind of interesting now is if you're up for 2013 or 2010 configuration, you still need to go for the KCD way. So you need to go ahead and configure the Kerberos constraint delegation for the WAP boxes, really. So either go for a single box, as in my lab I have a single box over here, or in your environment you will have multiple boxes, which kind of means I will need to have a alternate service account configured up there. So I need to, if I want to do a KCD to a multiple number of CAS boxes, I need to come up with an alternate service account for 2010, 2013, and go ahead and add the shared name as an HTTP SPN to the delegation up here. All right. If you're going for 2013 SP1, that's obviously going to change for you because you can use ADFS credentials or the ADFS way of authentication there. All right. Jumping back, if you want to do the KCD way and your Exchange server and domain controllers or web servers, that's actually the question that I'm going to answer. So the gentleman just asked if when using web with KCD, must the web box be in the same domain? Not necessarily. If you have a bunch of pre-requirements met, like Windows 2012. So Windows 2012 introduced a way for KCD to work across domains and across forests, really. So you can have a look at the link I copied in. I demoed it with the web server being in a root domain and the Exchange server being in a child domain, and it worked just fine. So this should actually work across forests, really, if you want to. All right. So documentation is in there, and here's a quick snippet, really, of how to set it. So there's no way to set the delegation in Active Directory users and computers anymore. If you want cross-forest, cross-domain, KCD, you need to set it via PowerShell, simple PowerShell commandlet, where you want to have the delegation pointed out to. So in this scenario here, I'm going to point the delegation from a child domain to a parent domain. That's about it. All right, just quickly walking you through, you just install the remote access role in 2012 R2. It's going to ask you for configuration, and it's going to ask you for federation service name. So this federation service name is the ADFS instance that you have. So as you can see, you cannot even complete the installation of the Web Application Proxy without having an ADFS box in there. So it's going to ask you for that. It's going to ask you for a certificate you want to use, so you need to have certificate for ADFS and for the application you want to publish, obviously. All right, and with that being done, you're just going to go ahead and publish your application. All right, so in my case, I'm going to go for ADFS, and it's going to show me the relying party trusts I created before. So we said relying party trusts are the way of ADFS, the way ADFS knows that it has to flow out credentials out of itself. So these are the configuration steps for KCD. If you want to give it a go, just take these and put it in your lab. They should work just fine. All right, and one for the road really. This came down from the web product group directly. They asked us for OWA ECP deployments to disable the URL translation in request headers. I just copied the appropriate screenshot in there. The idea is that Web Application Proxy would rewrite any URLs that come in request headers really, and it seems that OWA ECP link doesn't really do well with that. All right, another quick caveat I wanted to make you aware of is SNI. So SNI is a server name indicator header. The idea is that the Web Application Proxy or the ADFS box itself does no longer utilize IIS in the backend. So if you install ADFS or if you install ADFS proxy or the Web Application Proxy, there will not be any more IIS installed in the backend. So if you would do that in 2008 R2, there would always be like an IIS instance running along with that. In 2012 R2, we're no longer going to do that, so there is not going to be any IIS anymore. The way we do it is that we feed all the requests into HTTP-sys directly. And the way HTTP-sys does this is to serve up certificates based on the SNI header sent. So we would expect the client to send an SNI header. The thing is that older clients, like old EAS devices, old ActiveSync devices, or older operating system like Windows XP, for example, don't support sending SNI headers. So if you have a client that looks like that and you published everything correctly, that's what you're going to see. You're going to see Internet Explorer cannot display the web page, yada, yada, yada. So there's nothing going to show up really. The problem is that XP, the HTTP stack of XP just doesn't send that, or the HTTP stack of all the ActiveSync devices just doesn't send that. All right, so there's a way around that. You can assign a default certificate for those applications that do not show an SNI header, and you're just going to add that up here right at the commandlets for your reference. And as soon as you assign a default certificate for that scenario, you're going to see your application as you have published it. So in that case, it's just Outlook 2013 again. All right. Last and final scenario I wanted to make you aware of. So what we came up with is a kind of a scenario where we have two companies. Let's say Fabricam.com is a hoster or whatever really at that stage. And you have a second company in there, it's Contoso.com. And Contoso.com holds the actual users. So the user accounts are actually stored in Contoso.com. And the thing is, Contoso.com doesn't have Exchange. They want to buy our Exchange resources. So what we can come up with is a solution that Contoso.com can use their own credentials, like user@contoso.local, sign on onto mailfabricam.com with his credentials from Contoso.com, and we can make the claim that we get back from ADFS, make that claim work against our Exchange environment. So the value proposition of this is that you can have your users use their own credentials from Contoso.com in that scenario, work against mailboxes that are actually in Fabricam.com and log on to those without any forest trusts in place, with nothing in place really. This works with ADFS authentication for Exchange. This also works with KCD authentication for Exchange. So the trick behind that is that we are rewriting UPN claims. So a simple scenario, so you could dream up way more complex scenarios, but a simple scenario is a scenario where I wanted to do a rewrite of the UPN claim. So I get in a claim that's called, for example, user@contoso.com, and I'm going to rewrite that claim to user@fabricam.com, which is actually an account that I have in my environment. All right. There's a bunch of more stuff in the slide text. There's like 3 or 4 more slides, which is basically 2007, 2010 coexistence. So yes, 2010 works just fine with pre-authentication. 2007 has a small caveat. It can only do pass-through, except if you're okay with proxying to a single server, then you could do pre-authentication as well. This has to do with the fact that 2007 has no alternate service account credentials and stuff like that. All right, cool. Bunch of notes. If you do a lab deployment and you have it sitting there for 2 weeks or so, so this happened to me quite a while. I'm always building out labs, and after a while of not using the labs, like 10 days, 15, 20 days not using the lab just dies. For web, this is for the moment a by design thing. The thing is that if you don't use web for 15 days, the thing is the communication between WAP and ADFS is secured by a short-lived certificate that's going to be renewed every 15 days. And if you hit those 15 days and didn't start WAP in the meantime, the configuration will be stranded. So in a production, that should be a non-issue because you will not turn off your publishing solution for 15 days. But in a lab environment, it could easily happen for you. Easy steps, you can just do the configuration again. As seeing that the configuration is stored in ADFS, you just need to repoint it to its ADFS instance, and it should start working immediately again. The registry key is in there. Just set it, just rerun the configuration wizard, and be done with it. Last thing I want to talk about is the external logout. We have kind of like TMG SB2 brought. We have a soft external logout. So what we can do is say, okay, you have an AD logout policy that says you have, after 5 tries, please log out my account. So you can now go ahead and say to web, yep, dear web, if a user tries for 3 times to log onto this account with a wrong password, do a soft logout for a couple of minutes, really. So it's kind of like the same thing that TMG had in its days. A couple of steps to configure here. You need to enable, disable it. We need to have a threshold, which is really just saying, okay, how many times do we want the user to be able to log on before being soft logged out? And we give it an observation window, which is just saying, okay, after X number of minutes, this user can try to log on again. All right, so I'll just quickly jump to a demo. And the demo that I want to show you is, I hope you can still see that. The demo that I want to show you really is a simple demo to start with. So what I have here is an ADFS box, really, and the ADFS box has its relying party trust configured. And the first thing is we're just plainly going to publish, simply go ahead and publish OWA to the internet, really. And I'm just going to give it a name, OWA. It's going to ask me for a URL, which is going to be, again, my test environment. And it's going to ask me for a certificate for that. And that's about it, right? So at that stage, I have published OWA with the Web Application Proxy. And if I go ahead now on my client and go to that URL, I'm just going to clear my browser cache here for a second. I'm just going to jump there, and what I was expecting to be seeing is the ADFS logon window. So in that case, I'm just going to log on with my credentials from the test user, and it's supposed to be logging me on to Outlook Web Access 2013 directly. So very simple. The only thing that I really did now is a publishing rule, and in the back end we have a relying party trust. So relying party trust, again, the component in ADFS that allows us to have credentials or claim information flowing out of ADFS. And as you can see, it successfully logged me on to Outlook Web App 2013. All right, let's take this a step further. I talked about cross-forest logons, and that's what I actually want to demo to you. So what I want to demo to you is I have a second forest in here. It's called seer2.at, and this guy has no exchange in it. It's just a plain domain controller with ADFS and a web box in it. What I'm going to do is I'm going to do a relying party trust here as well. I'm going to say, yep, I'm going to trust seer1.at with my exchange work, and I'm going to do an ADFS trust there. So I'm going to say, yep, and this is going to be ADFS seer1.at at that stage. Let's see if it's actually working. Yep, looks good. Okay, And it's asking me if I want to do a claims rule there, and I want to give my the first forest, I want to give him my user principal name. So what's going to happen now is I have a second forest in here, and from that second forest, I'm going to issue a UPN claim. So at that stage, we're going to have that guy, which is in forest 2, give my UPN claim to the guy in forest 1. And the only thing we still need to do is have the guy in forest 1 accept the claim, really. And that's what I'm going to do here. Keep in mind, this is a very simple demo with no security built in, so you would want to build more security around that. So I'm just doing a simple UPN rewrite, which is not the most secure thing on the planet to do. But you could dream up many more stuff, so it's just really a technology demo at that stage. All right, so I'm going to say, yep, I'm going to get in a claim. And the claim that I'm going to get in is a UPN claim. And the claim that I want to issue, again, to Exchange is a UPN claim. But I want to replace the suffix of the claim. So we don't really care what suffix is coming in. We're just going to add, I'm just going to give it a name, really. Not that it matters, but I'm just going to give it a name there. What's not going to happen is that if I log on again, just going to claim a browser cache again, we should see something happening there. All right, so it's not going to ask me which forest are you actually from. Are you from SIR1? Are you actually from SIR2? So there are ways to automate this, but for the time being, it's just going to ask me for which forest you're from. So I'm just going to say I'm from SIR2, really. So in that case, if you can look up there, I got bounced over to the other forest. So let's go in there, and I kind of created like a shadow account in there. So I'm not going to log on with this account over there. And what ADFS is not going to do, ADFS in the second forest is going to issue the claim for test E2K13 at SIR2.local, going to give it to the ADFS box in forest 1. ADFS in forest 1 is going to rewrite the claim to test E2K13 at SIR1.local, which should actually be understood by Exchange. So we're going to show the same claim, the modified claim, to Exchange, and as you can now see, I actually logged on with a account from a different AD forest without having any Exchange trust at all to this guy's mailbox, which is quite cool. So you can dream up much more scenarios than that, really. It's just supposed to be really a quick technology demo. All right. That's it for the presentation. That's it for the demos. Thanks for listening. I'm just going to work my way through the documentation, through the questions, really. So there was one question from Jorge saying, when using Web Application, we kind of answered that. When in different forests, what are the trust requirements? So the trust requirements, have a look at the link that's actually in the PowerPoint file. It's listing the requirements in there. There was a second question from Shah. If we're using RSR for two-factor authentication, and if RSR is configured for geo-redundancy between regions, will this work for redundancy in the future and not relying on LB? So for the second question, I'm not aware of that. For the second question, I'm not aware of that. There's plans to build in NLB in Web. And for the first question, as soon as you have a claim and the claim and the web box, as soon as you have an edge access cookie, and you show the same edge access cookie to the web boxes, and the web boxes are joined to the same ADFS farm, you shouldn't get an additional authentication prompt, because the web boxes, as soon as they're joined to the same ADFS farm, should be able to decrypt it because they share the same encryption key. So I think the answer is it's actually not dependent on RSA. Okay, two more questions. Where's the PowerPoint file? The PowerPoint file should be attached. So if you're in the link call, there is a button called Attachments here, and I attached it there. If you can't see it there, I'm sure Nicola can let you have it afterwards. Last question there, can you continue to use forms-based authentication and just use pass-through for all services? Yes, you can. If you do not care for pre-authentication, you can just use form-based authentication. Next question is, how is Outlook handled if you move the Auto-Discover to web servers? So Auto-Discover at the moment is pre-authentication only, and you should see no change in how Auto-Discover works. I might not be understanding that question totally. If you have a deeper intent to that, just let me know.